Okay, so now we have found out the total combined or effective capacitance of this whole circuit. So breaking the 6 microfarad, we got as 2 microfarad capacitor, and now we have a circuit which is in parallel, and now we have break this complex circuit into one single capacitor, which is 4 microfarad and 2 microfarad has been solved into one 6 microfarad capacitor. So always remember, capacitors in series circuit is just the opposite of resistors in series circuit. Okay, the formula. And also for capacitors in parallel is just the opposite of capacitors in resistors in a parallel circuit. So if you can see here, you can see that when you have a parallel circuit, the formula is just C1 plus C2, whereas for resistors it was 1 divided by R1 plus 1 divided by R2 is equal to 1 divided by R total. So always remember, it's just the opposite. So now once we have found the effective capacitance, which is this one, now it's asking us to find, so this is already found. Now it's asking us to find the charge and voltage across each capacitor. Okay, so we know that the voltage across 2 microfarad and 4 microfarad is automatically going to be 100 volt itself, because it is a parallel circuit. So remember, voltage always stays in a same as the power supply in a parallel circuit. So EMF is always going to be equal to voltage across capacitor 1 and voltage across capacitor 2. Okay, and in a series circuit it would be, so for example in this case it's going to be voltage 1 and this is going to be voltage 2 and this is going to be voltage 3. So when we add V1 plus V2 plus V3, it's going to be equal to EMF or total voltage. So in a series always it's going to be the sum. Okay, so V total is always going to be, V total or EMF is the same. Okay, is going to be, which means the voltage from the power supply is going to be always equal to the sum of all voltages across the components. So here you have V1, V2 and V3. Okay, so we need to find this voltage which is across these three capacitors, and we know the voltage across this one is 100. Okay, so for that we need to first find the charge. So looking at the charge, so how do we find charge? What is the formula for charge? Q is equal to C times V. So we know that the charge is going to be equal to sorry, it was not this one. Yeah, apologies, it was it's this question, we already finished that one. So yes, so we know that Q is equal to 1 minute. Okay, so we know that Q is equal to, I'm going to write here on this side, C times V. So we know the first one. Okay, so we're going to find the charge for 4 microfarad. So farad, again it's capacitance, so 4 microfarad times, and we know the voltage is 100. So you're going to get your charge as 400 microcoulomb. Okay, so either you convert it or you keep it as the same. So once you got the charge across this one, now we need to find the charge across this sector. So remember, this was solved into one equivalent resistor, and that was a 2 microfarad. So it was, so if you're drawing the diagram, it was like this. and this is the 2 microfarad, and this was 4 microfarad, and this was your 100 volt power supply. Okay, so we need to find this one. So it's going to be again the same. Q is equal to C times V. So it's going to be C is 2 microfarad times 100 volts. So you're going to get your Q across 2 microfarad as 200 microcoulomb. So remember, even if you don't change the micro in capacitance, it's very common because, like I said, capacitors are known as micro, nano, etc. Yes, they're known as microcoulomb. Microfarad, nanofarad, etc., picofarad, etc. It's very usual to see capacitors in that values. So even if you don't change, it is fine. But for other problems, make sure you always convert it into the standard format and remove the micro, nano, kilo, etc. and put it in its standard format. Yeah, so once you got 400 microcoulomb and once you got 200 microcoulomb, now, so we got what is voltage across this line, and we also got the charge across this capacitor and across this simplified capacitor, which is 2 microfarad. Now, we also know the charge will always remain same across individual capacitor also. So it's going to be 200 microcoulomb across all the 6 microfarad capacitors. Now we need to find the voltage, because remember I said you the voltage changes, okay? So V1, and this is V2, and this is V3. So we need to find what is V1, what is V2, V3. But we know that when we add V1, V2 and V3, it's going to be equal to 100 volt, which is the EMF. So again, the same formula, which is Q is equal to Q is equal to C times V. But this time we don't know what is voltage. But we know the capacitance, which is, yeah, so we don't need to find here because we already know it's 100. But we need to find here. So it's going to be 6 microfarad capacitance times voltage. We don't know. And we know what is the charge. So it is, the charge is 200 microcoulomb. So remember I said you the charge stays the same for all the microfarad, all the capacitors, all the 3 capacitors. So it's how do you make V as a subject, and then you get 200 microcoulomb divided by 6 microfarads. And then you're going to get your voltage, which is 3. Yeah, I'm going to write it here. So it's going to be 33.3 volts. That's your answer. Okay. So that's your voltage across capacitor 1, capacitor 2 and capacitor 3. So now when you add 33.3 and 33.3 and 33.3, you are going to get 100. So V total is equal to V1 plus V2 plus V3. So if you do that, 33.3 plus 33.3 plus 33.3, you are going to get 100. So that means it's right.